This presentation will introduce installation procedures, starting with the site preparation, working through assembly and backfilling, and spending some time on flow equalizers. Then we'll finish with a discussion about effluent filters. Site preparation will vary by state, but will always require the removal of the organic materials from the dispersal area. This includes grass, shrubs, any forest mat, and trees. Consult your Presby manual for how to deal with stumps and topsoil removal. If the topsoil is left in place, mix system sand into the top few inches of the material to create a transition layer for the treated effluent to easily enter the subsoil. If the topsoil is removed, prepare the receiving soils as described in the Presby manual. Techniques vary according to state requirements. Once the receiving surfaces have been prepared, place the required system sand on the very same day. This protects the native soil structure from being damaged during construction. Tracked equipment is recommended to minimize soil compaction in the area of the field. Keep construction equipment off any soils downslope of the new field. The future performance of the system can be seriously affected if these soils become compacted. Keep surface water from running into the prepared bed during construction, and never work wet or frozen soils. As we discussed earlier, when placing advanced enviroseptic pipe into the prepared field, the bioaccelerator fabric must be located at the bottom. This will always place the sewn seam at the top. AES pipe is supplied in 10-foot lengths, but can be easily cut with a utility knife and saw to any desired length. To assemble the pipe sections into a row, begin by placing the two sections to be joined end to end. Then pull the fabric layers back far enough to place a coupling under each pipe. And again, remember to orient the bioaccelerator fabric at the bottom. The coupling ridges should engage the valleys of both pipes. One end of the coupling has a locking tab that gets pushed into a mating slot on the other side of the coupling. Push the tab into the slot as far as it will go. Now pull the geotextile fabric over the edges of the coupling. There will not be enough fabric to completely cover the entire fitting. This is normal. There only needs to be enough coverage to stop sand infiltration. To assemble the offset adapters on the ends of the rows, start by pulling the fabric layers back. Then place the adapter over the row end and push the adapter until the adapter's locking tabs are captured by the pipe's valley. Pull the fabric back over the edge of the adapter to stop sand infiltration. You should now rotate the adapter until the hole is oriented in the 12 o'clock position. To join the rows for serial distribution, use 4-inch diameter plastic to construct the raised connections. Schedule 20 to Schedule 40 can be used. All joints should be solvent welded. These connections should extend 2 to 4 inches inside the offset adapter. If the pipe extends too far into the adapter, it can place the end of the pipe underwater, which would eliminate the possibility of any airflow. Once the connection is inserted into the adapter, lift the connection until the top of the elbow is level with the top of the AES pipe. This is why we call this a raised connection. Push system sand below the pipe to maintain its position. This same procedure is used to construct vent manifolds. A sloping serial bed layout is pictured here. This installer is using the raised connections along with grade stakes to maintain row spacing during assembly. The AES pipes are grouped at the top of the system sand bed and you'll notice the system sand extension on the downslope side. Using a wooden frame to maintain row spacing is another way to hold the pipes in place during backfilling. Rebar frames have also been used. If the field is constructed level, it may be enough to shovel a sand berm against the sides of each row to hold them in place during backfill. You could also find it useful to cover the rows in several locations along the bed before covering the entire field. Remember to place the sand slowly, or the row spacing will change. Cover all the rows with system sand until they are firmly held in place. Then straddle the pipe and walk in the spaces between the rows to eliminate any possible sand voids around the pipe. This process of walking the rows may need to be done more than once. Make sure the rows have at least 2 inches of system sand on top of them before attempting this procedure. The rows may lift as the sand is forced under them if there isn't enough weight holding the pipes down. After the sand voids have been eliminated, continue to place system sand until there are at least 3 inches of cover on the field. A minimum of 4 inches of topsoil can now be placed directly onto the system sand. A permeable geotextile fabric may be placed on top of the system sand before laying the topsoil, but it is not required. Venting is an important part of a healthy system, and as we've already mentioned, all systems have 2 vents, one high vent and one low vent. Air is meant to enter the low vent and exit the high vent. If the system is gravity fed, there will only be a low vent attached to the field, and the home's roof stack will serve as the high vent. If the system incorporates a pump to deliver effluent to the field, an additional high vent must be added to the D-box. These systems are said to have differential venting, which refers to the difference in height between the low and high vent openings. The low vent opening must extend far enough above the finish grade to keep it above snow, but it can never be less than 1 foot above grade. Remember, this refers to the vent opening. Vents attached to the field can never be less than 4 inches in diameter, and the building's roof stack should be 3 inches in diameter. Low vent piping can be constructed of Schedule 35 plastic, but high vents should be made from Schedule 40 for structural strength. Be sure to glue all joints. Never use a charcoal filter on a vent stack. It will restrict airflow and possibly suffocate the field. Differential venting is used when pumping to a distribution box and then gravity feeding to the field. Because the pump line eliminates the possibility of airflow back to the building roof stack, a high vent is attached to the D-box. The high vent must be anchored to a support post. Never use a flow equalizer on the D-box outlet used by the high vent. It will only restrict airflow. The distance from the opening of the high vent to the opening of the low vent must be at least 10 feet. If the high vent is taken upslope, the change in elevation is counted toward the required 10 feet. For example, it's possible that the high vent is taken upslope enough so that it need only extend a short distance above grade to keep it above snow, but the total difference in elevation from the high vent opening to the low vent opening is still 10 feet or greater. It is common to remotely locate the vent stacks to help disguise them in shrubs or at a tree line. Be sure to follow the construction requirements outlined in the Presby Manual to ensure proper airflow through the field. At no time should any portion of the vent system ever extend into the water table. Bypass venting may be allowed in your state and is a way to eliminate the need for a high vent attached to the D-box. Check your manual for details. Pictured here are two ways to disguise the low vent. The vent stacks are hidden inside the body of the granite post or inside the base of the bird bath. Both these items are available through our distributors. When creating the finished grades, be sure to crown the topsoil over the field so as to shed water away from the system. Be sure to redirect any upslope runoff away from the field as well. Never plant any deep-rooted vegetation or install irrigation systems directly over the field. Flow equalizers are used when effluent is being divided within a distribution box and is meant to compensate for out-of-level D-boxes. A flow equalizer is not needed if a D-box is using only one outlet, as would be the case for a basic serial layout. During installation, the equalizers are all adjusted to the same liquid level. The narrow slot is always installed pointing down. When pumping to a D-box with equalizers, remember to limit the liquid delivery to no more than 20 gallons per minute per equalizer, although 10 gallons per minute per equalizer is preferred. For example, in the D-box pictured here, 2 outlets are being used, so the pump cannot deliver more than 40 gallons per minute. More than this will overwhelm the equalizers. Never place an equalizer on a D-box outlet used for a vent. Effluent filters are used widely as a means of retaining solids within the septic tank. AES systems are not as susceptible to the suspended solids that get past a working septic tank baffle as are traditional systems. The AES pipe acts as an additional settling chamber and is able to digest the material before it reaches the biomat. Effluent filters require regular maintenance, oftentimes more than once a year. When left unattended, they can clog and restrict airflow. Because Advanced Enviroseptic is more tolerant of suspended solids and the potential for poor filter maintenance resulting in restricted airflow, we do not recommend their use unless they are mandated by the laws of your state. The primary topic of this presentation was installation, starting with site preparation, which includes the removal of all organic materials from the proposed dispersal area. Once the receiving area is prepared, the system sand must be placed on the same day. Field assembly is easily accomplished by joining sections of AES pipe with couplings until the desired row length is achieved. If necessary, the pipe can be shortened with a utility knife and saw. The white bioaccelerator fabric is always placed at the bottom, which will naturally place the sewn seam at the top. Offset adapters are installed on all ends of AES rows with the holes in the 12 o'clock position. The rows are then attached one to another by means of raised connections. Backfilling involves carefully placing system sand over the pipes and removing any sand voids by walking the rows. We learned that all systems have both a high and a low vent. Discussed how flow equalizers are important to evenly divide flow, and finally, how effluent filters are not needed or recommended for use with the Advanced Enviroseptic system. If they are required, they must get the necessary maintenance or they could cause harm to the field.